video for Unit 7, AP Classroom, FRQ Progress Check A. So you're given this, this idea here. First of all, no calculators allowed for this. And you're given this idea that there's a vat filled with the saltwater solution. The solution with a higher concentration of salt flows into the vat. A solution flows out of the vat at the same rate. So the number of pounds of salt in the vat at time t minutes is modeled by this function, where A is the amount, right? So A is the amount. So you got this dA over dt, which is a rate that is essentially directly proportional to itself. Now you have to kind of take what I would call a leap of faith on some of these. But notice that when time t equals 10 minutes, A is equal to 50 pounds. So write an equation of the tangent line at t equals 10 and use it to approximate the number of pounds of salt. So part A. So a tangent line is going to be y equals, or in this case, it's really A of t is approximately equal to the slope, which is 6 minus 0.02 times 50, because that was our given piece, times t minus 10 plus 50. There is our equation of our tangent line, so that's worth 1 point. And then you're just supposed to figure out what A of 12 is. So we really can just put in A of 12 is approximately equal to, now you really want to use the approximation sign because it's an approximation. I don't know that you'll be penalized, although this grading rubric on this one says that you will be. I don't remember them penalizing for you if you used equals, but to be safe, don't, because it's and you don't have to simplify that. You can leave it that way. You could go through and simplify it, but I certainly wouldn't. You can just leave it the way it is and you should get the right answer. So then we get to part B. And part B says show that this A of t satisfies this differential equation. Well, if it satisfies this differential equation, initially you kind of think, oh, I'm just going to do separation of variables, but there's an easier way. You're given A of t equaling 300 minus 250 e to the 0.2 minus 0.02 t. Figure out what A prime of t is. A prime of t would be negative 250 e to the 0.2 minus 0.02 t times negative 0.02. Well, so if we think about what that is, we're supposed to verify that negative 250 times negative 0.02 e to the 0.2 minus 0.02 t is equal to 6 minus 0.02 times A, which in this case A was 300 minus 250 e to the 0.2 minus 0.02 t. Now, that's really close to being an answer. In truth, if you want to verify this, the best thing that you can do is do the following, is actually just write, actually I'm going to write it without simplifying those negatives, is to write negative 0.02 e to the 0.2 minus 0.02 t equals 6. Actually, I'm not even going to write the 6. I'm just going to rewrite exactly what I have. And I'm going to write that. And I'm going to write that 50 needs to equal 300 minus 250 e to the 0.02 minus 0.2 minus 0.02, and then this needs to be, we're verifying that actually when we plug in 10 into here. And I would write 50 equals 50, and you don't have to really do the math behind it, but you have to show that you know what you're doing with the math behind it. That's the way I would do that part. It looks like a separation of variables, but it really doesn't. You don't have to do a separation of variables on that. That's not true in part C, and what I mean by that is look at this one. It says you got this differential equation. So they say C is equal to, they say in part C, they say dH dt is equal to negative k times the square root of h. And then they go on to say, that 0 goes with 16 and 30 goes with 4. And they say find h of t. So now we do have to do separation of variables. Remember, you're only moving variables, don't move constants. So h to the 1/2 to the h to the negative 1/2 dh is equal to negative k dt. So if I move that h to the 1/2 over to the other side, it becomes h to the negative 1/2. So then if we add 1 to the power, we get h to the 1/2 divided by 1/2 is equal to negative k times t plus c. So we have 2h to the 1/2 is equal to negative kt plus c. Now we're going to use our two initial conditions. Notice we have two constants. We have a k and we have a c. We've got two initial conditions to figure out what they are. So let's use 0, 16 first. So 2 times 16 to the 1/2 is equal to negative k times 0 plus c. 16 to the 1/2 is 4, so c is equal to 8. Now we're going to use that, and we're going to use 30 comma 4 because that's our other initial condition. And if we use 30 comma 4, we'll get 2 times 4 to the 1/2 is equal to negative k times 30 plus 8. So we have 2 times 2 equals negative k times 30 plus 8. And so we get 4, so we get negative 4 divided by negative 30 is equal to k, so k is just equal to 4 divided by 30. So here's what we have now. What we have at this point is we have 2 times h to the 1/2 equals negative 4 over 30 t plus 8, and we are just going to complete this one by just solving for h and not simplifying. So we multiply by 2. And we square both things. And we're done. And that's how you do that first one. You'll get better in the second one, promise. Keep the faith.